This is Mr. McGough. Today we're going to go over rational exponents. First, a little bit of a review. When we multiply two multinomials together, we're going to use distribution. We're going to take each element of the first multinomial, in this case a trinomial, and we're going to multiply it by each element of the second. So 2x squared times negative x squared is negative 2x to the fourth. When we multiply numbers with exponents together, the same base number, in this case x, then we add the exponents together. So then we go 2x squared times 3x, so that's plus 6x cubed. 2x squared times plus 6 plus 12x squared. Next, pick another color. The second term we're going to multiply by each of the terms in the second trinomial. And we'll line these up as we go along. So 4x times negative x squared is negative 4x cubed. 4x times positive 3x is plus 12x squared. And then 4x times plus 6 is plus 24x. One more color. Now we're going to go negative 5, the last term of the first trinomial, times each of the terms in the second. Negative 5 times negative x squared. Negative times a negative is a positive, so that's plus 5x squared. Negative 5 times positive 3x is minus 15x. Negative 5 times plus 6 is minus 30. And now we'll sum. So for the x to the fourth power term, we have negative 2x to the fourth. We'll check our answers. So we can immediately eliminate b. Next, 6x cubed minus 4x cubed is plus 2x cubed. The next term on C does not have an x cubed term. That one's gone. D does not have an x cubed term. That one's gone. We'll go ahead and finish just to make sure that A still matches up. 12x squared plus 12x squared plus 5x squared is 29x squared. 24x minus 15x is plus 9x, and then we have minus 30 at the end. So 2x squared plus 2x plus 29x squared plus 9x minus 30. A is our answer. Simplifying, I to the 76th power plus 12 to the 0. Well, any number to the 0 power is just 1. So we'll add that at the end. I to the 76th power. Well, on day 5, we discussed I being the square root of negative 1. And when we square it, we get negative 1. If we take that and square it, which is the same as taking I squared, which is I to the fourth power, it's the same as negative 1 squared, which becomes positive 1. So we have an even power, so we know I is going to go away when we simplify I to the 76th. We just have to figure out if that's divisible by 4 or only by, we end up with a remainder of 2. So we will go 4 goes into 76 19 times. So 4 will go evenly in with no remainder, so it is a divisible by 4 power, so it will be positive 1. So 1 plus 1 is 2. Now moving on to the next bit of material here. First off, numbers with a rational exponent. A rational number is one that can be described as a ratio of a over b, where a and b are integers, and b does not equal 0, or you'll get division by 0 and it'll be undefined. So a rational number is a ratio of two integers. The way that we use this when we're looking at rational exponents means the exponent is a rational number So let's call it x to the a over b. What that really means is the bth root of x to the a power. It'll make more sense as we do some examples. So number 1, 9 to the 1/2 power is the same as the second root of 9 to the first power. Second root, square root. Normally we don't even write that number up there because we use it so commonly. So the square root of 9 is 3. 27 to the 1/3 power means the bth root, the third root of 27 to the first power. So we'll take a look at factoring 27. 27 is 3 times 9. 9 is 3 times 3. We're taking a third root of this. So we need to collect factors in triplets, in groups of 3. So the third root of 27 is 3. Negative 4 to the 1/2. So it'll be negative the second root of 4 to the first power. 4 to the first power is 4. The square root of 4 is 2. So this simplifies to negative 2. Negative 64 to the 1/2 power. That means the second root of negative 64 to the first power. The factors for negative 64 are negative 1 and 64, and then 64 has factors of 8 times 8. I could go further, but I don't need to because I'm looking for pairs. So I have a pair of 8s. I can take the 8 out front, and I have 8 times the square root of negative 1. We all know, however, now that negative 1, if it's inside the square root, that is I. So the answer to number 4 is 8i. Number 5, negative 8y to the 6th, all of that raised to the 1/3 power. So here we have the third root of negative 8y to the 6th to the first power, which I won't bother writing the first power. 8 is 2 times 2 times 2. We could leave the negative assigned to each 2, because a negative times a negative is a positive, and then we multiply by it a negative again, and it becomes negative again. So negative 2 is a factor. Y to the 6th is really y times y times y times y times y times y. So we can pull them out in groups of 3. Or we could just divide the exponent by 3 and see if we have any remainders. Any remainders would stay inside the radical symbol. However, here we have, oops, I said radical symbol and I wrote one. Here we have negative 2 times y squared. 2 groups, that's y, that's y. So cube root of y cubed, cube root of y cubed, each one of those becomes a y. 16 to the 1/4 means the fourth root of 16 to the first power. 16 is 4 times 4. 4 is 2 times 2. So here, we're going to take out a group of 4. Since this is 2 to the 4th, the fourth root of 2 to the 4th is 2. Number 7, 32x cubed to the 1/2 power. So this is the square root of 32x cubed. 32 is 16 times 2. 16 is 4 times 4. So here we have a perfect square. X cubed is x times x squared. X squared is also a perfect square. So we could take a 4 and an x out. But we still have a 2x inside. No problem. We write that as 4x times the square root of 2x. Number 8, 16 to the 1/3 means the third root of 16. 16 is 2 times 8. 8 is a perfect cube of 2 times 2 times 2. So the cube root of 16 is 2 times the cube root of 2, because there's still one more 2. Whoops, what did I just do? 2 still stuck inside there. Moving on. Now we're going to rewrite in radical form and simplify. For number 9, 25 to the 3 halves. So this is again a rational exponent where the top is what we're going to raise the 25 to, and the bottom is the root that we're taking of it. 25 cubed is 25 times 25 times 25. So we can take out a pair for our square root, and then we still have 25. Square root of 25, 25 is 5 times 5. So the square root of 25 is 5. So we have a 25 times 5 equals 125. You can always try that on your calculator as well. Using your up arrow, your caret, you could actually go 25 raised to the parentheses 3 divided by 2 and hit equals, or you could write that in as 1.5 instead of 3 halves. Or you can go 25 cubed and then take the square root. Number 10, 4 to the 5 halves is square root of 4 to the 5th. Our rules of exponents say that all we really need to do is divide this by 2. So that's 4 squared. We can take 4 squared out. And then I still have 1 remainder. Well, what's the square root of 4? That's 2. So it's 4 squared, which is 16, times 2, which is 32. So again, you can always check these in your calculator. Next one, 8w cubed raised to the 4/3 power. This means, and I'm going to change pen colors just to make it easier to see, this will be the cube root of 8w cubed raised to the 4th power, which is the same as saying the cube root of 8 to the 4th power times w to the 3rd to the 4th. Rules for exponents. A power of a power. We multiply the two exponents together. We could also do it with the 8, because we actually should know by now that 8 is really 2 cubed. So this could be rewritten as 2 to the 12th times w to the 12th. Oops, 12th. When we take the cube root of that, we take our exponent and we divide that by our root. So this will be 2 to the 4th times w to the 4th. If you want to work it out, 2 to the 4th is 16, so 16 w to the 4th. Number 12, 27 to the 2/3. Third root of 27 squared. If we recognize 27 as 3 times 3 times 3, or 3 to the 3rd, then we have 3 to the 3rd squared, which is 3 to the 6th. If we take the 3rd root of that, we get 3 squared, or 9. And that is the last problem on this page. Let's go ahead and take a look at the next page. 2 to the 3 halves will be bottom number, square root, 2 to the top number, 2 cubed. So here, we could also have reduced it there as well, but this is 2 times 2 times 2. We're taking a square root, so we're going to take out pairs. So we'll take out a pair of 2's, and we'll have a 2 on the outside, and then we'll still have a square root of 2 on the inside. 4 times x to the 4.5 power, or 9/2 power, and all of that's being raised to the 2/3. So it'll be the third root, or cube root, of 4 squared times x to the 9th power, which is 4.5 times 2, or 4.5 x to the 4.5 power, then squared, we multiply those two exponents together, power to a power rule. So 4 squared, 4 is 2 times 2. Squaring that's 2 times 2 as well. So we'll take out a triplet of 2's. There's going to be a 2 left behind inside of the radical. So cube root, we got a 2 out, we left a 2 in. Next, x to the 9th. Taking the cube root of x to the 9th, we'll see if it's an even ability for 3 to go into 9. There is no leftovers inside of the radical, and we get out x cubed. So 2x cubed times the cube root of 2. Number 15, 3 to the 4 halves. Well, we recognize 4 halves. 4 divided by 2 is 2. So that's really just saying the same thing as 3 squared. We know 3 squared is 9. Number 16, negative 4 to the 3 halves. Well, let's see. This is going to be the square root of negative 4 cubed. Well, negative 4 cubed is negative 4 times negative 4 times negative 4. Each of those negative 4's, in fact, these two would become positive, so I can just say that's 2 times 2 times 2 times 2, and then up front here is times 2 times 2 times negative 1. And negative 1 is important. We'll come back for that in a moment. But we're going to go ahead and take out pairs because it's a square root. So I have a pair of 2's, I have another pair of 2's, and I have yet another pair of 2's. So I get a 2 times 2 times 2 out in front of the radical, and then inside the radical I have that negative 1. So this actually reduces then. 2 times 2 times 2 is 8, and the square root of negative 1 is I. So that is 8i. Rewrite in exponential form. Let's see, that's the square root of 6, which is 6 to the 1/2. And then I'm going to raise that to the 5th power. Rules of exponents. A power to a power. We multiply the two powers together. Is 6. 1/2 times 5 is 5 halves. Number 18. Cube root of 7 to the 8th will be 7 to the 8th over 3. The other way to look at this. B is 3. A is 8. So it's 7 to the 8 over 3. Square root of 8. Well, we're going to rewrite that in exponential form. So we can rewrite it as 8 to the 1/2. That's true. Or we can recognize that 8 is really 2 cubed. We'd be raising that to the 1/2. So we'd use our rule of exponents. We multiply our exponents together. So that's 2 to the 3 halves. And last one, number 20. Cube root of 9. Oops. Cube root of 9, which we could rewrite as 9 to the 1/3 power. It's totally acceptable. Or we can recognize that 9 is really 3 squared. So 3 squared to the 1/3 power. We multiply our powers together, and that's 3 to the 2/3. We could have also looked at it as the cube root of 3 squared, and that would get us to 3 to the 2/3 as well. So make sure you practice those to go through the homework for the day, and thank you for watching.